Hello, my name is Barbara Wajnchold and I represent InPhoTech. During next 10 minutes, I would like to say a few words about our company as well as our ideas. And I will try to convince you that microstructure optical fibers are very interesting, not only because of scientific possibilities, but also it is a great opportunity for future communication technologies. InPhoTech is an R&D company providing photonic technology and services tailored to the client. What is important, our technology and patents are fully polished and are independent on other worldwide technologies. InPhoTech activities present a whole chain from the beginning, from the idea to the prototype. From defining the needs, possibilities, designing the fiber and the device, manufacturing preforms, drawing optical fibers. And next, post-processing, like coatings and bonding fiber to the relevant material, and glass processing. And at the end, preparing prototype and test it. InPhoTech specialized in optical fibers for special purposes, such as sensing applications and light sources, but also we are doing optical fibers and optical fiber components for telecom. As you could see, optical fiber technology, it is something more than standard telecom fiber, which is providing light for your internet. Here we present our structures developed for different purposes. There are microstructure optical fibers. They usually consist of solid core, which is surrounded by air holes, such as small capillaries. And that structure helps to change optical and mechanical properties of the fiber. For example, we have a pointer? No. So, sorry. That one structure, this is the structure which was developed for bending sensing. And for example, that one. And this is for light source, broadband light source. And these are one here. And these are multicolor optical fibers developed for both sensing as well as telecom applications. And now I would like say a few words more about these multicolor optical fibers. All you know that communication, speed of light, speed of communication information and its flow is extremely important. But also size is very important parameter for telecom, and very often that parameter decide, of course, among others, but usually decide on the final price of services. So a while ago, optical fibers start to displace copper cables, but we want to go further and we want to use one optical fiber instead of bundle of optical fibers. So the multicolor optical fiber is our answer to the global need for speed. It allows to increase density of information in one fiber through increasing number of cores. So at the end, we receive in the same size of cable more information. So we propose passive and active multicolor optical fibers, and fan in, fan out, the device which is linking multicolor optical fibers with the standard single mode, single core optical fibers. And on the same technology is based optical fiber splitter, which is suitable also for nowadays telecom nets. Generally speaking, the optical fiber should provide the highest possible density and compatibility with nowadays standards. It helps us to implement it in nowadays nets. So our multicore optical fibers has usually the same or very close parameters such as geometrical, mechanical, and optical properties as standard single core fibers used nowadays in telecom. So, for example, there are single mode, and each mode is compatible with single mode fibers, standard single mode fibers. Air holes which surround every core prevent crosstalks and bend losses, as well as the outside diameter is compatible with standard fibers. We develop also active erbidium fiber for amplifiers. And that fiber, we plan also that will be suitable for space applications, so it will be insensitive to radiation and temperature changes. As I said at the beginning, we develop system which fits to current systems, current nets. So the very important question is how to address and read out all 7 cores and link it to the nowadays nets. So of course you could do in such big device which are proposed by some guys, but in our opinion it's quite quite difficult, and of course it's very expensive. So we've proposed also all optical fan-in, fan-out, which is linking standard telecom fibers with our multicore fiber. How small is it, and that it's possible to do it? I bring it one to you, you could see. And also on the exposition there is the prototype of fan-in, fan-out and multicore optical fiber. Fan-in, it's for introducing light to the multicore fiber, and fan-out for bringing out. Yeah, okay, yeah, sure. So what's more, based on the same technology, it is also possible to develop also some optical fiber splitters. These are made by connecting single mode fiber with multicore fiber and the fan-out device. And we splice it and taper it, and during the tapering, light from the central core is divided onto all these 7 cores, as you could see on the film which was recorded during tapering the fiber. So that splitter, comparing to the nowadays splitters, is less expensive, and has nowadays it has comparable losses and homogeneity, but it is only prototype, so we believe that it will be better. So summing up, I would like to say that optical fibers, especially microstructure optical fibers, it is technology which could help us to create better future, better communication technologies. And I would like to invite you to join us and create it with us and our fibers. And I would like to thank you all sponsors on funding agency who believe that our potential is something what we need in the future. Thank you for your attention.
Any questions? So,
okay, of course. Yeah. Mm. Mm-hmm. Could I beg or not?
można puścić wstecz?
No, I couldn't beg. Okay, so no matter.
We were working on it.
Hmm?
Sorry, we were working on it.
Okay, no matter. So that fiber, as I said, it's for telecom, but also could be also for sensing. For example, pressure, temperature, also chemical sensor based on such microstructure optical fibers. For example, one of the application, one of prototype which is now preparing for manufacturing is the optical fiber sensor for flow meters, which is extremely sensitive, and because there's no electricity inside, so it's suitable also for explosive environment. So this is one of the application where you could see optical fibers. And one very nice property of the optical fiber sensors is possibility of the distributed sensing, that you have hundreds of kilometers of fiber and you could measure in the same net through the fiber every meter, for example, pressure or temperature, for example.
Okay, I'd like to ask one question. So your company is based on deep scientific research. Can you tell me something more about your origins? Who are the people that built the company?
Yes. So our head is a guy who worked many years in university in Brussels, but very close to the industry. So we have such big industry push in our company, and we are about 30 people now in company, and from different aspects we try to connect optical fibers. For example, I'm material engineering, but also we have guys from chemistry, we have guys from physics and electronics and so on, and we try to connect all these applications together. And we have also few people from industry who came to us from optical fiber industry. So as you maybe it's also important to say that Poland is starting to a very important country in that worldwide microstructure optical fiber world, I could say, because we are opening now our manufacturing of these fibers. So this is not only possibility of prototypes, but also hundreds of kilometers of such fibers.
Thank you.
In Rzeszów.
Any more questions? Okay, and maybe one more question for the end. I'm curious, who are your potential clients? What kind of company is your buyer, potential buyer of your technology?
So, for example, for that flow meter, this is a big German company specialized in measurements, but also we have industry from telecom. We have also actually also one industry from coal mines, because they also want to measure by optical fibers their air, for example. So very different applications. But as you saw, also we have project with Airbus Defence and Space that for satellite applications. So very different.
Very interesting. Thank you so much.
Thank you.